Now the last topic I want to talk about is something called holes, okay? Now, sometimes instead of there being an asymptote, gosh, I do that all the time. Sometime, instead of an asymptote being created, where there's a function is not defined, right? So these asymptotes, I'll just draw a quick one over here. We have an asymptote like that, and then it pops down like this. Here's an asymptote right there. Sometimes of those being created, a function is not defined, a hole is created because there are two factors, identical factors, in the numerator and the denominator, okay? And so those two identical factors cancel each other off, creating a hole, a blank point. So here's a function, you can graph in it, and there's just a hole there. Just this point just does not defined. And this graph right here comes from this function right here. You can write this down. We got f of x is equal to x squared minus 9 all over x minus 3. And I'm going to show you what happens. Now, if you were to look at this function, you could say, oh, this function isn't defined when x is equal to negative or positive 3, because if you put a 3 in for here, we have 3 minus 3, which is 0. And so a lot of students would just jump to the conclusion, oh, well, that's where there's an asymptote, when x is equal to 3. But there's no asymptote in this situation, and I'll show you why. Show you what happens. Check this out. If you were going to factor the numerator, we factor that numerator, we do it in our heads. You can do a little x thing, right? You put the negative 9 on the bottom, 0 on top. What times what is that? So we have plus 3 minus 3. So we factor, we have x plus 3, x minus 3. Okay, I factored that really fast. I'm sorry for everyone. That's what I was doing. And then on the bottom, I still have my x minus 3. Okay? So what happens here is, notice that this x minus 3 and this x minus 3 cancel out, leaving us with just the x plus 3. So if you were to graph f of x equals x plus 3, or this is kind of the same thing as y equals x plus 3, you start at 3, and you have a slope of 1, so you go up 1 over 1, up 1 over 1, up 1 over 1. So it looks like a very linear line, right? But remember, this wasn't the function. This is a simplified version of a function. The real function had this x minus 3 in here. And so because we had these two things together, they cancel each other off, creating this hole, black hole. It's not really a black hole. It's just a hole right here at this point, instead of an asymptote on a normal rational function. So that's what a hole is, and that's how you can decide or determine whether it's a hole or an asymptote when dealing with rational functions.